Today, it is time to apply a biome map to Espa. We will finally figure out what the landscape will be like on different parts of this planet. To do this, it was required we first do the atmospheric circulation map and the ocean currents. But with those out of the way, we can now finally get started on the big project. Let's start off with some context. Let's talk precipitation. Most rainfall will occur under low pressure areas, mainly in the intertropical convergence zone and the polar front, places affected by onshore winds, and regions subject to a warm coastal current. Reversely, the lowest amount of rainfall can be expected to happen around high pressure areas, mainly the subtropical ridges, where the winds blow either offshore or parallel to the landmass, areas affected by the cold coastal currents, and/or continental interiors. Context 2. Temperature. The highest temperatures can be found at the equator, or the interior of continents, and the lowest temperatures will occur towards the poles or the shorelines. Season-wise, the largest temperature variations will occur on the coast as opposed to the continental interior. And then finally, mountains will also play a role in being able to block rainfall moving inland from the coast. If there is a tall mountain range, rainfall will be concentrated on the windward side, while the offward side will be dry. Alright, that's everything ready. Strap yourselves in because this will be a long one. Let's start with our tropical climates. Espa's tropical climate will extend about 20 degrees north and south of the equator. In this tropical zone, 3 subclimates can be found: tropical rainforests, tropical monsoons, and tropical deserts. Let's start with the tropical rainforests, which are hot and wet all year round. Think the Amazon or Indonesia, marked by very dense forests, little underbrush, poor soil quality, and very high biodiversity. Espan rainforests can be found between 12 degrees north and south of the equator. From this zone, we subtract areas that are mountainous, affected by cold coastal currents, or are inside the rain shadow cast by mountains. Here in the far west, the mountains trap a lot of cooling wet air, which means rainfall is extremely high, even though it's far north of the tropical rainforests. Due to cold currents in the Thick Ocean, most of the rainforests don't reach the western coast of Vantamere. In the Sona Peninsula, the coasts are affected by cold currents, which means that even though the northern interior is densely forested, the coastlines will not be. Even though it's a tropical rainforest on most of Sona, it avoids the coastline. And additionally, to the east of the peninsula, there's a rain shadow cast by the Urus Mountains. The central mountains of Vantamere are eroded and not as tall, so the rain shadow is significantly smaller. Moving eastwards, the situation is reversed, and the coasts are now affected by warm currents, bringing plenty of rainfall. Eastern Vantamere, a region which I will call Sinimayu, will resemble the Amazonian coastline. Affected by the warm current, the rainforest will move even further north and south. Here my work starts to really pay off, because this will result in a tropical rainforest well over twice the size of the Amazon. These islands in the middle of the Raoul Ocean will also be completely rainforested. Then we arrive in the far eastern continent of Ijuatl. There are even more tropical rainforests to be found here. There's mountains and cold currents in the east and 2 rain shadows in the north. To the east, the warm currents take over, and a vast tropical island paradise emerges around Ihan. Especially around Ihan, I can extend the forests much further north. Back on the eastern part, there's a small patch affected by cold currents here, which will interrupt the rainforest. There's also a large but eroded mountain patch in the center of Ijuatl, which will cast a rain shadow westwards, linking up with the cold current. Then back to the east again, the rainforest traced the coastline affected by the large amount of rainfall. Globally, tropical rainforests cover about 3.4% of the entire planet's surface, amounting for a combined size of 18 times that of the Amazon rainforest. This is good because I need this to facilitate the absolutely massive oxygen concentrations in the ESPAN atmosphere. Our next stop is the tropical Savannah, with hot, wet summers but long and dry winters. Think The Lion King. Shrubs and tall grasses with few lone trees, frequent droughts and low biodiversity. Lion eats gazelle, gazelle eats grass, food cycle 100. These savannas can be found in the low-lying regions surrounding the rainforest, between 5 and 20 degrees from the equator. Let's start by removing the highlands from these zones. While a warm current is present, the region can extend significantly further from the equator. Across Ventimiglia, once more huge strips of dry savanna are filled in, spawning across most of Sona and southern Ventimiglia. We also have a small strip of coastal savanna on the southern continent of Kishko. Across Ijuatl, we can also find huge savanna lands. Next up are my hot deserts, with very hot and very dry summers and warm dry winters. Think the Sahara Desert. Sand dunes, some rocks, sand dunes, no vegetation, save the occasional shrub, sand dunes, low biodiversity, and oh yeah, more sand dunes. These deserts can be found between 12 and 35 degrees from the equator and ideally should not directly touch the savannas. And I'll show why in a bit. The driest areas are affected by cold coastal currents and/or offshore winds. On Ventimiglia, a huge desert forms around this area in the north and around this sea. In the south of Ventimiglia, only relatively small patches of desert have a chance to flourish. Another huge desert forms in Kishko, while northern Ijuatl has some fractured desert patches except in the east. This northern continent also forms a smaller, albeit still large desert. In the south of Ijuatl, another big desert forms though. Now all that's left to do is to fill in the transition zones between these, starting with the hot steppe. Think the Sahel. Hot steppes are hot, low and dry regions, but have non-zero rainfall between 12 and 38 degrees from the equator. Hot steppes are a transition zone between the desert, which is ideally where we will place them, as well as places that were just a little too wet to become a fully fledged desert. Across Ventimiglia, we have thin bands of steppes, except here in the western peninsula, which is affected by just too much rainfall. Tropical monsoons are hot and wet all year round, except during the summers, which are short and dry. Think southeast of India. These zones are found between 12 and 25 degrees on Espa, mainly as a transitional zone between the rainforests and the savannas. Monsoon circulations are when the winds reverse for part of the year. This is what happens of an equatorial ocean between 30 degrees of the equator. You get a monsoon climate. Espa has a few of these regions, but no grand candidates like India is on Earth. And with this we can finish the Hadley cell on Espa. Let's get started on the Ferrel cell next, which extends from 35 to 70 degrees from the equator. This region is mostly grouped as a humid continental climate, warm summers with moderate rainfall, with cold winters with low rainfall. Think Western Russia. Then there are subarctic continental climates, with short, cool to mild summers, moderate rainfall, and long, very cold and dry winters. Think Siberia. I can place these between 50 and 75 degrees from the equator. Normally this climate won't reach as far south as 50 degrees unless affected by cold currents and/or offshore winds. Meaning you will often get it to curve on an angle, as you can see here on the continent south of Ijuatl. This peninsula in the north has a tiny coastline in the south affected by warm offshore winds, making it too wet. Applying this everywhere, we get this. Don't worry about the poles, we will do those last. So next up are the subtropical climates. Starting with the Mediterranean climates with hot, dry summers and mild winters with moderate rainfall. Think Italy and Greece. On Espa, we find Mediterranean climates between about 35 and 50 degrees, in mostly coastal regions affected by cold currents. On the southern hemisphere there are small patches, except around the bay in Kishko, and around the strait south of Ijuatl. On Ventimiglia, I'm stretching it quite a bit far south, because I would like to use the north side of this strait as a springboard for civilizations. Not really unrealistic, but maybe a bit unlikely. Regardless, inner circulation of the sea should cool the region enough to facilitate it. The peninsula here will also host a lot of this biome, perhaps an early springboard when humans settle beyond Ventimiglia in the future. Providing a possible springboard, all the way to Ijuat. Mediterranean climates are important on Earth because they have the best climate to develop agriculture, historically. Now, it's hard to say at this point that the first ESPAN civilizations will sprout in these regions, but it is the first lead we have, and if I deviate from it, I will need to give logical reasons why ESPAN crops might be different, animals aren't domesticatable, or something else. Next is Humid Subtropical, with hot wet summers and mild winters with moderate rainfall. Think of the American South or Lower China. Some trees, ferns, bushes and shrubs and even grasslands can be found here. I'll place these between 28 and 48 degrees, in regions affected by warm currents. In effect, they should usually be on the opposite side of the continents from the Mediterranean climates. Which is why I have changed it here in the southern strait of Ijuat's smaller gyre, so different biomes on each side of the strait. There's also a thin strip here next to the mountains. Finally, let's do our oceanic climates, with mild wet summers and cool wet winters. Think the Netherlands. They have no dry season, low temperature flux, lush forests and a ton of rain all year round. Seriously, it never stops. These go between 45 and 65 degrees in regions affected by warm currents, which puts them primarily on the western side of the southern continents, because the north has really poor conditions for this biome except on this peninsula here. The coastal regions of this biome, especially on this peninsula, are covered by temperate rainforests. Continuing ever on, we have cold deserts with hot, dry summers and cold, dry winters. Think the Gobi Desert in Mongolia. I can place these anywhere in the feral cell in the continental interior's rain shadows or on the highlands. The largest cold desert is right here on Vantamere. Finally, we have the cold steppes with warm, dry summers and cold, dry winters. Think Crimea. These will again serve primarily as a transition zone with the cold deserts and also with the hot steppe. Makes sense, those steppes are getting cooler as we move towards the poles. Finally, I can subtract the mountains from the humid continental zone, and that's the entire feral cell all finished. This leaves only the polar cell, which has only 2 subdivisions. Let's start with the tundra, with cold, low rain summers and long, very cold and dry winters. Think Iceland. Marked by permafrost, no trees, some shrubs, grasses, moss and lichens, low biodiversity, and during the summer, seasonal lakes and bogs appear from the meltwater. On Espa, these are found between 68 and 82 degrees from the equator. Then, last but not least, we have the polar ice cap. These are areas which are permanently covered in ice sheets. Think Greenland or Antarctica. Since I already stated that Espa can't have much of these, I shall use them extremely sparingly, but not leave them out entirely, putting them primarily inland, which is where land ice can best form. Espa's ice caps are found primarily on the northern hemisphere, where there is a huge polar continent, and only very small ice caps exist in the extreme south of Kishko. Then, as the cherry on the cake, we can fill in the remaining mountainous areas across the planet. And with that, we have finally finished a Köppen-Climate map of the planet. This was one of the longer videos because, surprise surprise, there's a lot of complexity to a planet's climate. I do believe that for now I have gotten a lot done for the planet. I still want to finish a complete topographical map and then make the planet's rivers. But this will probably take a while, so in the meantime I think I want to try to populate this thus far bald planet. That's right, fellows. It's speculative evolution time. This will likely take me a while to prepare properly though, because it will be my first try ever at Spec Evo. I hope you enjoyed this video, and I do apologize if this turns out to be the last video in a while, but I'll still see you next time. Stay tuned.